Hi, thanks everyone for joining our webinar today. This is Greg Potabon. I head up business development for SecPod Technologies. Today we're going to discuss cyber hygiene, and while that perhaps is uncool, it's certainly a necessary task to manage security risk. Specifically, we'll talk about ways to simplify and automate endpoint patching to mitigate risk. Please submit your questions during the presentation. We will then answer the questions toward the end of this webinar. Chandra, our CEO, will discuss endpoint security hygiene and an approach to simplify and automate patching to mitigate endpoint security risk. So let's get started.
Hello, everyone. Thank you, Greg, for the introduction. So my name is Chandra. I am the founder and CEO of SecPod Technologies. Good morning and good evening, and thanks for joining this webinar, taking time out of your schedule. So this topic is cyber hygiene, how to perform this perhaps a basic step in the layers of security that needs to be built for protecting any organization. So over the last couple of decades, I have had the opportunity to discuss with industry colleagues working in the information security domain, working in large enterprises, mid-sized companies, and also the SMEs, along with the managed services provider and also managed security services provider. Typically, the conversation is, of course, around how to protect from attacks or how to defend an attack. Now, generally, the discussion gets into how or why attacks continue to occur in spite of investing in large number of tools. And most of them admit that they have invested in so many products, but it is not actually helping resolving the security or mitigating these security risks or preventing an attack from occurring. So there are an array of products that are out there, and most organizations help buy invest in these security products, but actually there is no solution. So many products and apparently no value or no security or assurance that is supposed to be provided with that investment. Of course, we all know the security onion or the layered architecture that needs to be implemented in order to defend against any attack. And that is how it has been all along, whether it is physical security or information security, and even in the military, for example, the military science and technology has been evolving over centuries, but some of these basic things remain as is. So there are certain hygiene things that needs to be implemented and managed as one of the primary layer in that security onion type of an architecture. Now, the reason why the attacks continue to occur is because there is one primary layer that is kind of wide open, and some of the basic cyber hygiene needs are not being implemented. And even if an organization wishes to do those or implement these criteria, the tools ecosystem is not really encouraging. So today's session is about understanding why the tools ecosystem is not supportive and how we can resolve that problem that is there in the industry. Now, if you analyze any of the attacks that have been occurring in the recent past, majority of them tend to be around exploiting a well-known vulnerability. So talk about Eternal Blue, WannaCry, Trill, Meltdown, Spectre, or Reaper, or Wade Through. Any of these attacks, if you analyze, you'll always see that there are some of these vulnerabilities that have been there, widely published but unpatched system. And so that kind of sets the agenda for today's webinar. Having said that, let me use the help of statistics to bring out my uh, assessment about the cyber hygiene requirement. So we all know endpoints form 90% of any organization's asset list. So you have the desktop, laptops, and servers and mobile devices, etc., which are IP enabled or IP connected to the network. And these endpoints generally tend to get the least attention. So most of the investment that is made around protecting endpoints is typically an anti-malware solution. And beyond that, we don't generally think about endpoints, but we look at the perimeter level security. Another interesting statistics, 80 to 90% of the attacks, as I explained earlier, some of the malware or the ransomware attacks that have been occurring is because of an unpatched vulnerability. And these vulnerabilities that are wide open and published and not patched, and some of these systems are not hardened, running with some default configurations, etc. So typically, a vulnerability comes in through a vulnerability in either the operating system and the third-party applications that we use on a day-to-day basis, and then spread from one system to another system using some of the default configurations that are not hardened in majority of these devices. Another finding from IDC said that 70% of the attacks begin at endpoints, so the endpoints have become the primary target these days because the ease with which you can perform an attack. So it's pretty easy to send out some email or allow or make someone download a particular file and then exploit a vulnerability that is there in the supporting application and then get into that particular system and then spread from that system to another system. And that has been typically the attack vector that is being followed by majority of the exploiters today. So if we just analyze the NIST CVE database itself, there were around 14,000 plus vulnerabilities published in the last year. So that averages to about 38 vulnerability per day. And these are some things that were published in the CVE database, but there are good percentage of these vulnerabilities that are not making into the CVE. So this number could easily go up to about 50 to 60 vulnerability being identified on a day-to-day basis. And that is a huge number. So a progressive organization would have implemented some of these things. So have a risk assessment software and maybe have a patch management solution to mitigate some of these vulnerabilities, etc. Even then, they take about 30 to 120 days to really apply these patches. And there are a large number of problems or the challenges why this is being done that way. Why are we taking about 3 to 4 months to patch a vulnerability that is published and vendor has released a patch, but we are not able to roll out? So there are a good number of reasons which we will talk about. So some of these indicators or the statistics really reveal fundamental problems that are there in implementing this defense mechanism, or the first layer that I would like to call as a primary defense mechanism. And it is not working, and that is how the attacks are occurring or continue to occur today. Now let's look at some of these challenges that are being faced by organizations today, and why we are not able to implement that basic primary defense mechanism. So one of the problem is that we don't have visibility to all the assets and the devices that are there inside our perimeter. So without as visibility, there's no way that we can secure any of these organizations' assets, and that is a primary requirement. And having visibility on a periodic basis, like once in a month, etc., if you run a asset scanning, that's not really enough. In dynamic age, BYD scenario, and then there is traveling workforce, and all of these complicate this further. So we need to have an ongoing or a continuous visibility to all the IT assets, the devices that are being managed and secured. So we need to know what kind of applications are installed, what operating systems are running. Is there a software that is out of support or end of life? Is there some application or an adware that is running that should not be running? So is there a quick way to get all of these to the minute? So that is one of the requirement of today. And that is not being implemented in most of the scenario. The second problem is the endpoint vulnerability. As I talked earlier, endpoints have hundreds of critical vulnerabilities. So I said about 50 to 60 new vulnerabilities are being discovered in the operating system and third-party applications, and ransomware and malware tend to make use of these vulnerabilities that are there. Now, one of the problems that has been there is a risk assessment exercise that we do on an ongoing basis, but the periodicity is once in a month or once in a quarter. While the new vulnerabilities are being discovered on a day-to-day basis, performing a monthly or a quarterly auditing exercise or a risk assessment exercise is just not enough. Now, auditing is definitely an important step, but it is a secondary check and not a primary risk assessment exercise. This is something that needs to happen on a much more uh, high periodicity than the monthly and the quarterly basis. So we do risk assessment, and then there is an exercise of identifying what patches to roll out and what configuration fixes to apply. And that is a manual effort in mostly, and then we'll have to go through the report that is thrown out by these risk assessment software that runs into thousands of pages. And then the IT operations team is trying to identify the patches, pull those patches from somewhere, and then roll it out through if there is a patch management software. So this whole disconnect between the risk assessment and the mitigation actually causes a good amount of delay in pushing these patches. Of course, there are other challenges like the excessive system resource usage, and I don't want to be impacting the productivity of the workforce, so I don't want to run the scan during the working hours, and the network bandwidth issues and things like that that continue to hamper continuous assessment of the devices on a day-to-day basis. And then you have heterogeneous environment, so it's not just Windows, you'll have Linux, Mac, Android devices, and iOS devices, and some of these devices don't know what OS it is running, etc. So all of these continue to add complexity to the risk assessment process. Of course, there is a new problem that is confusion around perimeter. So the perimeter that used to exist more or less does not exist now with all the BYOD and the traveling workforces and offices in multiple geographic locations, and integration of customers and partner network and things like that. So all of these throw away the perimeter definition that used to exist earlier. So all of this In addition to that, there are these isolated teams, like the IT security team is cut off from the IT operations team with communication barrier and things like that. All of these only add to the delay of knowing what problems exist. It's really critical to know the problem that exists immediately and not like a monthly or a quarterly basis. So in physical security world as well, so knowing the risk is important at that time when the risk is created, as against knowing after a month or 3 months later. Now, I talked about security hardening requirement. Most of the attacks tend to use this approach to spread from one system to another system. And again, in order to become compliant to any of these benchmarks or the regulatory compliance requirement, we do a periodic or a quarterly or an annual assessment as against a continuous uh, security compliance, achieving security compliance continuously. So that's another problem that has been there. So all of these add to the delay and the complexity and number of tools that exist, and all of these tend to cause more delay into the IT management effort. Now, I mentioned earlier that today's product ecosystem is not really supportive in order to achieve the continuous risk assessment, continuous compliance status. So all of these products, point products, typically operate in silos, and you have these bloated feature set. Most of the organizations invest in 5 to 6 different products and technology, and majority of them are not being used or not really helping us achieve the security assurance that they need to provide. And you'll typically have multiple agents that are running, hampering the productivity and causing delays and things like that. And of course, bringing in any new product into the organization, there is cost involved. There's a deployment and risk management and compliance management, etc. So all of these tend to add to the complexity that is already there around managing and securing these devices. So with that introduction, I would like to mention that 90% of these attacks can be prevented with 8 simple steps. Those steps are maintain continuous visibility. We need to have a tool that provides up to the minute visibility to all the IT assets and the devices that are being managed. We need to know what all applications are running, what processes are running, and what is really installed in each of these systems. Are they all running an approved version of the software? Are there certain applications and the tools that are not supposed to be running are installed? So having visibility to each of these is extremely important, and that needs to be to the minute and not an outdated information that we are trying to assess risks based on that. And with continuous visibility, it is also important to perform an ongoing risk assessment. Again, this has to be a continuous activity and not a monthly or a quarterly exercise. I would recommend doing this on a daily basis, understanding what vulnerabilities are there, what configurations issues are there, and having clear visibility to the criticality of these vulnerabilities, etc. And of course, the tools that we would invest in should not cause the same problem that I discovered earlier: network resource, bandwidth, and productivity, and all of those concerns. And the third step is to have a mechanism to search for potential or high profile attacks So if we hear about WannaCry, I should have a quick mechanism to search across all my systems and find out immediately if that vulnerability exists, which is being exploited by WannaCry. So having a simple search console to know what risk is there, and if that risk is there, having an ability to go ahead and fix it immediately, or at least do some procedures to contain an attack if an attack were to happen. So that is the step number 3 or action number 3 that I would recommend. Also, it's important to have consolidated patching or a patch management environment as against multiple tools for patching the heterogeneous environment. So you cannot have something for Windows and then Linux and something for Mac OS X, and then you have another thing for applying third-party applications. It's really important to have a single console that helps me roll out these patches again on a day-to-day basis and fix those vulnerabilities immediately, at least if it is a critical vulnerability like WannaCry or Eternal Blue, something that you need to immediately roll out, and then have some process in place to roll out the other patches on an ongoing or a continuous basis. Applying these high critical patches immediately. So it's important to know that there is a high critical vulnerability that is there and that is being exploited by this particular malware or ransomware. And that needs to be patched immediately. So we need to have a single console that helps me perform all of these. Because we need to have a solution to cover traveling or roaming employees. So we cannot have them come over once in a while to the office and get them fully updated and patched and things like that, because new risks and malware and threats are being identified on a day-to-day basis. So no matter where they are, so they should be within the security perimeter that we build. So these employees' devices need to be covered on a continuous basis. Now, this is a critical thing. So a lot of these activities are being done manually, and that is when it becomes quite hard to perform these on a day-to-day basis. And large number of these can be automated. Of course, we wouldn't want to automatically roll out patches for a production environment, but the desktops and the laptops and the user devices can really be automated. The patches can be rolled down on a day-to-day basis as and when a new patch is available. And if something were to happen, you need to have a mechanism to roll back quickly so that the productivity is not impacted and there's no, at least have minimal downtime. And the last step is to enforce compliance to either the regulatory standards or have internal security benchmark of your own, and perform this assessment again on a continuous basis and roll out the fixes as and when a deviation is identified. And this has to be an automated exercise. We cannot have a quarterly audit and then identify the deviation and you fix it and another change comes in and then it becomes non-compliant. There should be a mechanism to identify such deviations and mitigate those. So no matter what time we do the secondary risk assessment exercise, we should ensure that the devices are fully adhering to a particular policy that we define. So those are the 8 steps, and these can be really simplified with the right set of tools. Just to recap, it's important to automate a lot of these activities, having continuous visibility to all the IT assets, what is running, what is not running, what shouldn't be running, having a risk assessment in place that performs again on a day-to-day basis, automate the patching for non-production environment and having a schedule in place for production environment patching. Then adhere to a particular a compliance benchmark. When I say adhere, it's not just the assessment, but also about fixing any deviations on an automated basis. And having a capability to perform an impact analysis if there is a high profile vulnerability or an attack that is taking place, we should have ability to search across all these devices and find out if those risks or threats are there. There is an indicator of attack or a compromise that we see that could be exploited by exploiters and attackers. Then apply these critical patches as and when such high profile attacks are detected. And then having an environment to patch through a consolidated approach as against multiple tools for patching multiple technologies. And then having solution to cover the traveling or the roaming users as well. So those are the 8 steps that could help prevent large number of attacks that are taking place today that we hear on a day-to-day basis. So just to recap, having a cyber hygiene practice and automating that to a greater extent can prevent good number of attacks. Need to have an up-to-date visibility, perform a risk assessment, patch those on priority and have that automated, and then fix those misconfigurations and achieve continuous compliance. And of course, with SecPod's Saner Now platform, all of these needs can be addressed through a single console. And our platform is a SaaS-based approach, brings in multiple tools into a single console. So we have multiple tools to address all the business needs around vulnerability management, patch management, asset management, endpoint management, compliance management, and endpoint threat detection and response tools. All of these are coming in together on a single platform. So this allows provisioning of the tools based on your need and use it as and when you need to use these tools. So with that, I would conclude my session, and I'll take another 10 minutes to go over the product quickly, not really cover all of the features and capabilities, but at least touch upon some of those things that I talked about. So this is a consolidated dashboard. It's a multi-tenant capable, which means you can have multiple accounts or sites created and manage them separately, and this gives you an overview from each of these tools. So we have an endpoint management tool, asset management tool, vulnerability management, patching, compliance, and EDR tool. So you can create multiple client accounts and sites from the control panel here. I have also multiple users logging in and managing these tools separately. So you can go into an individual site and get more details about that site. So each of these tools provide a little more information, like a vulnerability management tool identified these many vulnerabilities, criticality distribution, etc. Now this is an overview. So each of those tools have a dashboard of their own. So a vulnerability management tool, without clicking on a single button, these vulnerabilities are being identified on a day-to-day basis. A scheduled scan runs every day, and scan typically takes about 5 to 6 minutes to complete. And there are settings that can allow you to control the usage of CPU and put thresholds, etc. So without impacting the system productivity of the user. The scans are being performed in the background and the results are being continuously pushed onto the server. So on those four systems, these many vulnerabilities are found, and this is the criticality of each of these vulnerability. And this is where you do an interesting mapping around identifying all the high profile attacks that are there and that are using some of the vulnerabilities here to exploit. For example, well-known WannaCry ransomware made use of a vulnerability in Microsoft Windows SMB. These are the CVEs that were being exploited. Now, those vulnerabilities are present in these two systems. So that way you have visibility to all the critical vulnerabilities that need to be patched immediately. So this vulnerability management tool is a reporting tool. So you have other recently discovered vulnerabilities, aging of the vulnerability, etc. We also list the mitigation approaches and the patches that can be rolled out to fix all the vulnerabilities that are identified. Now, once we have visibility to the vulnerability, the next step is, of course, to fix those. So we have a patch management tool, identifies all the patches that need to be rolled out, the criticality, reboot is required, and things like that. These are the high-profile vulnerabilities that need to be patched based on the exploits and malware and the ransomware. There are other information related to patching, what patches are already installed, what is being installed, etc. So in order to install these patches, going into missing patches, select the application and the operating systems that we need to patch and create a job to roll out those patches and schedule the patching activity. There are filters to apply only critical patches, fetch patches based on the family of operating system. You can also fetch the patches by group and devices. We also have capabilities to fix misconfigurations driven by the compliance benchmark. There is another tool called CM that is a compliance management tool that helps define a compliance benchmark for any of the regulatory standard or the internal security benchmark. The deviations that were identified are listed here, so you can actually select those and fix those deviations to achieve full compliance. And all of these activity can be completely automated. So you can select the list of applications that you want to automatically patch, for example, and then create an automation rule. So as and when a new vulnerability is identified and if a patch is available for the selected asset, you go ahead and apply the patch at a particular predefined schedule. So the schedule can be a daily activity or a weekly or a monthly activity. You can also define the time frame by when the patching should be done. And if you want to go ahead and automatically reboot the system as part of the patching, you can select it to reboot the system as well. So this way, a large number of systems, which are the desktop, laptops, etc., can really be automated to roll out the patches. Similarly, the compliance deviations can also be automated. So by creating an automation rule, those patching activity can be tracked, whether they are successful or failure or any issues there, and if a reboot is required, for example. So all of those can be tracked in this. Apart from the patching, there is an asset management tool that gives an overview on all the IT assets, the hardware, software, helps manage the licenses, utilization, underutilization, etc. Tracks the end of life and end of support application, blacklisted applications, and some of the applications that are not being used after procuring. And then we have an endpoint management tool. There are two major capabilities here, the checks and the actions. So checks are quick ways to get information about all the endpoints. So if you want to know all the ports that are open, just a click away. This is a complete list of ports. in the services that it is, or the process that it is running. You can export this data into a CSV file. Another interesting thing that we provide is link a check to an action. So if you want to block or kill a particular process, I can go ahead and perform that by selecting these actions that are there. So there are a large number of checks like that available for each family of operating system. And these are quick ways to get every information that we need. So BIOS is outdated, for example, get the BIOS version and all of that. Consider upgrading those. So we also track endpoint security softwares like the AVs installed, updated, and running. There are tools to perform queries to detect data, PII or credit card, social security numbers. There's a way to track the system health, CPU, RAM, and disk utilization. So a lot of these tools are pre-built. There's nothing that kind of off the shelf. You just run it and you get information. Now, coupled with these checks are the actions. So any issue that you find, you have a way to fix those issues. So the entire Sena Now platform is built with this principle of not just knowing the problem, but also actually taking an action to mitigate that particular problem. So you have application and device control to block access to certain applications and devices, ability to deploy software applications and even uninstall certain applications, start, stop, or kill processes, make changes in the registry, restart services, perform network settings, reboot or shut down system, quarantine and delete files. So all of these capabilities help fix if there is any problem identified. Then we have a compliance management tool, helps create security benchmark based on the templates that we provide for NIST, PCI, and HIPAA, etc. So you can select any of these tools, customize the template according to your requirement by editing this template and creating a benchmark. So these are all different checks that we have mapped for the NIST requirement. Each of the operating system has anywhere between 500 to 600 different checks that can be performed. So once we have this carefully crafted, we apply that benchmark to select groups. And those devices that are part of the groups will be assessed for this particular benchmark, and the report will be immediately shown here, a breakdown of that particular report, showing individual rule level detail of why something failed and what percentage of these devices are non-compliant. Then once you have that visibility, it's about taking actions. So you have the fixes that are listed that can be a patch can be, or a configuration application can be performed here. So that's compliance management. And finally, we have an EDR tool. The primary purpose is to build detection rules. So we have large number of checks that can be performed. So if you want to know a process abc.exe is running, so we have a process query that you can create based on these attributes, and then also create combination of these rules put together into a single group, and then deploy these to selected devices where I want to run this query. So these queries will be sent to all the agents, all the endpoints, and they will come back with the findings, and then you will know if such an indicator of attack exists or not. And then you have response rules that you can create to make specific changes immediately as part of that identification. So that's an EDR tool. Of course, as part of the platform, we have standard reports that you can export out into a PDF. Each tool has its own report. You can schedule the report, send out emails. We have alerts email-based alerts once again to, based on an occurrence of a particular event, you can create an email alerts and you can track all the users and the actions being performed by each of the user, etc. And you can also control the behavior of the agent, like what time to run the scan, how to remediate, etc. through settings that can be applied to individual group of devices. So that is a quick overview of our product. With that, I would like to conclude my sessions today. Open for any questions.
I see there are currently a couple of questions, Chandra, that perhaps you could address.
Yeah. Let me open the...
And everybody else, feel free to submit additional questions. As you can see, the 6 tools as part of the Nano Platform support endpoint security hygiene in a number of different ways through vulnerability scanning, patching, compliance, asset management. All that's handled with one agent.
You open the question. There is a question from Ahmad. How is the management agent, if one is necessarily, rolled out across endpoint platforms? So today we have agents for all Microsoft platform, major distributions of Linux and Mac OS X. So the Android and the iPhone the agents are being developed at this point. So these agents can be rolled out through multiple deployment options. If there is a software deployment tool already in place, you can deploy it through that. We also have our own tool that can help deploy it across all the endpoint systems. It can also be rolled out through an Active Directory GPO policy if it is a Microsoft environment. Another question from Muhammad. Would you consider this an RMM tool as well as are complementary to an RMM? A lot of these capabilities can be seen as an overlapping functionalities when you look at RMM functionalities and ours. So the primary difference is that we are looking at it more from the security angle. So we identify the vulnerability, we have tools to detect potential symptoms of an attack, and there are application control, device control, etc. So the primary angle that we are coming from is security point of view. Yes, there are RMM tools that provide asset management and patch management, etc. So we do have a good patch management tool that covers all of the different platforms and third-party applications, and pretty good at that when compared to the RMM tools. There is a question from Brandon. Can you go through the patching? Would like to see how that is done. Okay, let me share screen once again. Hope all of you can see the screen. So there is a patch management tool available here. So that lists all the patches. You'll have to go to missing patches, select the application. So all the identified patches are listed here, and you have the size and if reboot required and how many hosts are impacted, etc. So you can select the patch and then apply selected patches, give a name. If you want to reboot the system as part of the patching, you can turn it on. Otherwise, you select the schedule when you would like to patch right now after daily scan or at a particular date. So you can specify the date when you would like to patch and then define a time frame. So this is how you can create a patch. There are filters available based on groups and devices and criticality, etc. There is also an automation rule that you can create specifying the list of applications that you want to automatically patch as and when a new patch and vulnerability is identified. Now, once you create a job, those jobs can be tracked, the status. So these are the patches that were installed on an Ubuntu system successfully. And if a patch requires reboot, if you have not selected reboot there, it will show the reboot status, reboot needed status there, and you can select the device and click on reboot, and a message will be broadcasted to that user, and the reboot can be scheduled in the next few minutes. So that is how you patch. All of these patches primarily are driven from the vulnerabilities that were identified part of the VM tool. There are these other patches that are not necessarily because of vulnerability, but general updates. So even those can be fixed by selecting the individual KB items and then roll out those patches. Okay, looking at the
question about Linux patching.
Yeah, there was. Can you show? There was a question. Can you show in more detailed example of the patch management of Srina? No, I think I covered that. And question from Akash: the product also cover Linux patching all flavors? Yes. So major distributions of Linux can be patched. So we cover Red Hat, CentOS, Fedora, Oracle Linux, Debian, Ubuntu, and Amazon Linux at this point in time. So we do cover Linux packages as well as third-party applications that may be installed on those systems. Another question from Ahmad: how is the management age? Oh, sorry, back to the first question, I guess.
So it's Srina now has a multi-tenant capability, so you can create as many client accounts as you want and then manage each of those. It builds agents specifically for each account that you can install at the client. So it has full capabilities around multi-tenancy. Are there other questions that people have? Let's see. Okay. We are pretty much coming up on the hour, unless people have other questions. Oh, there's another question here. And yes, you can roll back patches. There can be different situations that may create a need for that. And that's handled in Windows desktop servers as well as Linux systems. Other questions? Okay. If there aren't any more questions, Chandra, do you have any closing comments?
Yeah, I think thank you once again for joining this webinar and taking the time out of your schedule as part of the post-webinar email. So we will be sending out the recording and the slide and one of the technical paper that we have authored related to this. Feel free to reach out to us in case you need further information about our platform or technology. Thank you very much once again to all of you.
Thanks, everyone.